Okay, today is the second day of polynomials, and I want to talk about what we did yesterday. We were doing things like this. This is the end result, and why would I ever have a 0 in a synthetic division like that? Yes? Yeah, exactly. If this was like the constant, there was no x's, this is like a 0x. This would be like a -2, this would be like 4x squared, and this would be like x to the third. Right? Remember that? Okay. Now, if 3 is the 0, it's also known as a factor or a root, or the solution, then what's the factor that's going to go with this when it's all done? Yes, sir. X minus 3. That's important to get the distinction between. That's the root. That's the number that you put in and it makes the equation 0. And this is the factor. All right. So now, I want to go back for a second, and if the original problem, I think we just figured out, was going to be x to the third plus 4x squared plus 0 x's, we just throw that in to have a placeholder, minus 2. If I set this equal to 0, is that normal? Yeah, that's to find the what's? The zeros, the roots, the x-intercepts, okay? Then what if 3 is gonna work? What would happen if I put the 3 into this equation, like here and here and here? What would happen if I put the 3 into the equation? It would equal 0. That's the point of being a 0, right? So if you want to know if a number is going to work when it comes to synthetic, you could stick the number in the equation and find out if it's a 0. And if it is a 0, then the only bad thing is, all you'll know is that it's a factor, and you haven't actually factored it. You'll just know that, well, 3 will work, and therefore the factor is x minus 3, but you don't know the rest of the story. You don't know what it actually factored to. So if you know this thing here can be written like this, but you don't know these numbers, then you haven't really fixed much. So let's actually do this synthetic right now. Go ahead. And I just want you to know that I get sometimes they don't work, but you need to understand what that means. Mr. SH, did this one work? And how do you know it didn't work? All right. When I add these, I ended up with this ridiculously big, what is it, 63? Ridiculously big leftovers here of 61. Okay. There actually is something you could do with that to get your final answer, but we don't go that far yet. That's one of the things I'm going to show you today. All we just said in the past was, oh, it doesn't come out to 0, so it didn't work. All right, how could I have cheated? Tell me how to change this red number in the problem right up here. What could I have changed that to so that it would have worked? Negative 63, I agree. Because then this would have been a negative 63 right here. And then when I added them together, I would have got 0. Cool. Then tell me, what does it factor to? The whole point was to factor that red equation. Please write it down in factored form. Miss TC, what'd you get? All this is tell me what these mean. Almost done. Just tell me you want to tell me? You're telling me nobody knows how to do this? Okay. There we go. It's done. Unless that black one here can be factored again, can it? I don't think so. And therefore, we're done. We factored it. Not everything can be factored all the way down, you know, to like little x plus 2, x minus 2, x minus 7. Sometimes you get stuck with something like this that can't factor. Okay, cool. We factored it. Now let's talk about long division. This same exact problem could have been done with long division. And I want you to see how that would have worked. And you're going to learn how to do, and you're going to have a couple on your homework for tonight that are long divisions. I think, though, first I should talk about long division in general. Would you agree that 3 can go into 29, just not perfectly? Okay, 3 goes into 29 how many times? 9, and that makes 27. And notice the process that I use here. I figured out a number that would go here so that when I times this by that, it gives me that. Get what I'm saying? And then I actually have to make this the opposite of what it was, negative 27. And then I put these together and I get 2. Now, that being a 2 means I didn't have a remainder of 0. See what I mean? But I was going to try to show you today, what does that mean in the context of long division when you have a remainder? I wish in elementary school they would have never done this. 9 remainder 2 is the answer, because it really doesn't mean anything. I mean, it means something, but it doesn't help you much. What I wish they would have done is taught the kids to say that it's 9 and 2/3. You get what I just did there? Guess what happens when you multiply 3 times 9 and 2/3? You get 29. Does that make sense to you? All right, let's do another one like that. 5 goes into 61. Try it. You'll have a leftover, a remainder, and do it the smart way, please. Okay. Mr. V, does 5 go into 6? Oh, sure it does. 5 goes into 6 once. Okay. And if I go 5 times 1, notice what I'm doing here. That times that, I put it here. Makes it 5. What do I do with those two now? All right. Makes a 1. All right, move on. Miss H. What do I do now? Drop this 1 down. Okay. And now what? Guy in the pink. Don't like to say names in the video. 5 goes into 11 twice. I put a 2 up here. Then 2 times the 5 goes here, makes 10. And then notice, I have to make this the opposite. The reason I'm pointing out all these little steps is you're going to have to do the same thing, except these are going to be polynomials, not numbers. 11 minus the 10 is 1. And, oh, I have something left. The answer is not just 12. Miss D. What is the answer? 12 and. So you can't do that. We can't do the 0.2 thing. I like that thought. You're right. But you can't do that with polynomials because you're going to have stuff like x plus 1 over x plus 7. You can't get a decimal for that. See what I'm saying? So why don't you tell me as a fraction? Yeah, see what I did before? I took this, and you do this and this. 1/5. Notice it's not 12 times 1/5, because that'd be a really tiny number, right? That doesn't make any sense. It's 12 and 1/5, so it's actually, there's a little plus in there. Raise your hand if you had that one right. Okay, good. Now see if you can handle this one. Same steps. It really is. First thing you should think of is this times this is going to equal this. Just like when we were done on this other problem, this times this makes 29. Okay? So these two things multiplied are going to end up giving me this back. So I need to have a number here, and I've got to start with something. Who's got a smart idea? What do you think, Mr. B? Just an X, yes. And that's always a good place to start, actually. And then if you realize, oh, it didn't quite work, you can always tweak it from there. Because think about this. These are factors. Don't they usually have like x plus 2 and x plus 3, you know? Okay, so there's probably an x there. So if I take this x, and now what did I do last time? I multiplied. I can't just pick one and multiply by that. I got to multiply it by both things. So first the x and the x makes an x squared, and then the x times the 1 makes an x. Now, you might think I failed because this didn't match up perfectly with the numbers above it. But as long as the first term cancels out, which it will, as soon as I change both to the opposites of what they are, then x squared minus x squared cancels out and it's gone. And what's positive 2x and a negative x make? Plus x, or just x. And then I drop the 1 down just like before. See where we're going with this? Now I got to figure out what to put here. Like plus 3, except it's not that. What is it? Plus 1. Because when I put in a plus 1 right here, now I take the 1 times the x and the 1 times the 1, x plus 1. Cool. Make these the opposites of what they were. And they all cancel, and I have a 0 remainder, which means I have factored it. No remainder needed. All right, let me give you a little harder one. Pause for a second. Let me try that long division. All right, did you start with an x? Like I was saying before, that's kind of a good place to start. And then if I had multiplied this out and it hadn't matched, I'd have just adjusted and said maybe I should use a 2x or whatever. Okay, x times the x is x squared. X times the 4 is 4x. Please don't add them together. You make everything the opposite of what it was, and then you add them together. These will cancel, just like I wanted them to, and this becomes an x. Bring down the plus 4, and then that makes it really simple, plus 1. Raise your hand if you had that right. Okay, good. Now we're going to do a little more complicated one, and I'm going to cheat. You're going to know the answer ahead of time. That's the answer. Let me tell you, then let me ask you, what is the question? What goes inside the box? Underneath the box. What goes here? Come on, think backwards. We already know the answer, so what goes inside the box is when this is all multiplied out, it's 2x squared. You get where I'm going here? It's 2x squared, and then what? Well, outside and inside, which makes negative 14, and positive 5, which makes negative 9x, and then minus 35. Did I FOIL that out properly? I think I did. Okay. Then, what would we put here? Or 2x plus 5, either way. Let's do x minus 7. I like your idea. And then the question would look like this. And I know you already know the answer. You already saw the answer. But try to figure out how you would piece this together. Do the long division. Okay. How do I start? Just get me started. Cabela's.
So you first multiply it by 2x.
2x. Excellent. Now multiply that out for me.
And it's 2x squared minus 4x.
Next step in the front row. Okay, that's gone. Excellent. You changed that sign. That's good. And then you get what? 5x. All right. And then what? Good. Mr. Benno. A positive 5 sounds like a worthy effort. 5 times the x, 5x. 5 times the negative 7, negative 35. And you make them the opposites, and then they add up to 0. Since I have a 0 remainder, I know I got the answer. And it's 2x plus 5 and x minus 7. Raise your hand if you feel confident that you could do a simple one of those. Good. You have 2 of those and homework for today. And let me show you where those are. We're not ready to go just to your homework quite yet, but everybody go look at the homework with me. Okay. Sorry about this. Okay, there's the big, there we are, day 2. Now, do you remember that on day 1, yesterday's homework, I had you skip most of the very first page because they were all special problems that were not synthetic, they were long division. Now we're going to go back and do just 2 of them. So everybody look at problems 2 and 3, circle those, get to this page in your homework. And we're going to go back and do a couple longs. And I'll set this first one up for you just to make sure you don't get them backwards. The one that you start with here is the dividend. The dividend is in the den. You know, like bears go into a den to hibernate. Think of this as like the den. Okay? The dividend is in the den. The divisor is outside. And then we always just have to start with, what could I put here so that this times this and this and this can go here, here, and here? Any suggestions for the question mark? Remember me saying if you couldn't think of anything else, what did I say to put there? All right, let me put an x there. If I go x times x squared, I'm going to get x to the 3rd. Is that going to make my first term drop out? No, but it's close. And you know it's probably 2x. Put a 2x here times x squared. That'll be 2x to the 3rd, and yay. As long as the first term will drop out, you're doing it right. All right, so we know this is 2x plus something. And yeah, this one's going to, it'll take you a little bit of space. You'll take a little time to figure this all out, but your final answer might be like 2x plus 7 or whatever. And the next one's even a little more complicated, but again, you should be able to handle 2 and 3. I want to give you a warning before you get too far in this problem. Does anything feel wrong in here? There's no x squareds. So better go and move this over and say plus 0x squareds. If you don't have those placeholders, you're in for a world of hurt. Minus x plus what? You need that 0 in there. Otherwise, it won't line up and you'll just be very frustrated. Okay. Now, we're going to skip through to, I had you only do a few of those, and now the new stuff for today is on day 2. Now, the zeros of the function are -2 and +2. and -1 and +1. And I hope you were just thinking, okay, so you're saying that the equation looks like this. X plus 2 and x minus 2 and x plus 1 and x minus 1. And by the way, these always equal 0 because we're finding the zeros, right? Okay, so write this down. This is one of your homework questions. You're doing 6.2, problem 41. All right. Now the problem is that they say the leading term has to be 117x to the fourth. What? Well, I guess we have to multiply this out. And it's not nearly as scary as you might think. Because what's that part? X squared minus 4. And what's this part? X squared minus 1. And do you get that it's shaping up that when I actually multiply it out all with FOIL now, that I'm going to have an x to the fourth as my lead coefficient? Because x squared times x squared will make x to the fourth. So then all I got to do is slap in 117 somewhere. Can I just slap in 117 right here? No, that's going to change my roots. Where could I put the 117? On the outside. Very good. Okay. That's how you're going to do problems like 41, 42, and 44. And then I have these two problems drawn in. I want you to replace this slide, the one that has the zebra, well, there's more than one with zebra pelt on it. Picture of a side of a zebra. Problem 5, though, cross that off and replace it with two pictures. What do you think I want you to write for these limits? You need to practice writing limits. Limit of the function as x approaches 0. Or, I'm sorry, we've only done right and left limits. So limit of the function as x approaches infinity. If your x approaches infinity, are you to the right or are you to the left? If x approaches infinity, you are to the right. And then if you want the left-hand limit, limit of the function as x approaches negative infinity. And what are the limits? The answer to a limit, after it says equals, what's the thing you're giving? Okay, there's two things. There's this is the x and there's this is the y. So in the context of a graph like this, the y is your height. Try to remember the limits are the height of the function at a given x. All right, so let me do some simpler limits for a second. Do you remember doing sketching? This is back to some review of stuff that we've done. Like I gave you this. And you'd make a little sketch of it. On the right end, it might be down or up. On the left end, it might be down or up. But you can now write limit statements to describe the end values of this function. So would you please sketch it? And let's say that you end up with something like this. Bounces here, cuts through there, goes up there. And if this was like that, I would then have you write the limit statement. Limit of the function as x approaches infinity would be infinity if the picture looks like this. Because x approaches infinity is the right side. That's this one. And it's going towards infinity. Okay, that would be the right end limit. I want you to sketch it for me. This is a totally wrong sketch. I just whipped something up there. Make the correct sketch for this. And then tell me the limit statements for the right and the left end. I'll pause for a second while you give this a shot. After you've made your sketch, before you write your limits, after you've made your sketch, would you compare with the kid that I'm about to pair you with? I'm back. You should not have had it going up at the end, should you? Why not? Because the lead term is negative and therefore it has a sad ending. It's going down at the end. And it has a couple of roots that are important. One of them is at -3 and one of them is at +1. So let's just change it like that. And at this one, at the 0, which is 1, and that it gets confusing, isn't it? The multiplicity is 2. I'm going to say that again. At the 0, which is 1, the multiplicity is 2. Say that to a second grader and see if you can get them to understand it. The 0 is 1, and the multiplicity is 2. Okay, so that means it bounces. Okay, so if it bounces and it has to be going down here, then I know it must be like going like this, boing. And then this other one is a, ooh, it's a triple. The name for that is a snake. And since it's degree 5, what does that tell me? The other end must be going up, so I think this could possibly be right. What if I was questioning myself? Is there a way to test yourself? To check yourself, so to speak? Yes, before you wreck yourself on the test. You should probably check the y-intercept first, because the y-intercept is where? X equals 0. All right, so if x equals 0, I put a 0 here and a 0 here, and then all of a sudden I have 3 cubed, which is 27, and now it's -27, and then this is -1 squared, so that's just the plain old 1, and that means it's like it's gone. So then it's really just 3 to the third, but negative, so it's a big negative number, and that's what I had, was a negative number. Granted, it's not a very big negative number, but that doesn't really matter because this is just a sketch. So there, I tested at least one of the spots. It's pretty hard to have it wrong. Or sorry, if I test one of my spots and it's right, I've already tested the ends. I mean, I already know rules for those. So that if the middle part's right, then it's probably right. All right, so then last question about this. What is, if we've got a, instead of giving you a picture, what if I said the roots are 5 and -4. The lead coefficient is -6. My question is, what's the right end limit? How dare you not be able to read that? The lead coefficient is -6. What's the right end limit? The lim statement. Write it. Compare it with the kid next to you. Some of you need to wake up. You're looking a little lethargic. I do. I owe you one. All right. Yes. I don't even care what it does in the middle, but I do care that this lead coefficient is negative means it goes down on the right side. And therefore, since I asked you for the right limit, the limit of the function as x approaches infinity was always a given because I said to the right has to be positive infinity, then it would be negative infinity. Raise your hand if you had that one right. Okay, good. Now the little bit slightly harder. What's the left end limit? Think it through. Shouldn't be super difficult. Okay, so we know that on the right it's going down. How about on the left side? Well, that depends on the degree, right? Since we are only told that there are 2 roots and we aren't told what their multiplicities are, then we would have to assume that their multiplicities are 1, because that's kind of the default. Just like if I said x, you don't say, well, I thought you meant x to the third. If I just say x, you can assume it's a 1. All right, well then that must mean there's a degree of 1 for this. Let's like, you know, the multiplicity of 1 and a multiplicity of 1 on this means the total degree is 2. If it's an even thing, then what do the ends do? Do they match or are they different? They match, and therefore it must be going down over there, and therefore it must be the same thing except it's the left end, so you'd say negative infinity would be negative infinity. All right, so we've talked about limits enough. We've talked about synthetic briefly. I think it'd be a good idea to do synthetic to solve this. x to the third plus 3x squared minus x, no, minus 2x minus 6. And what do you need to know to be able to do synthetic? A root. So that implies that it's, so isn't a root the same thing as a 0? Doesn't that imply that this thing has to be set equal to 0? Okay, and then what if I just told you that I had put in a negative 3 into this equation and it had equaled 0? By telling you that negative 3 going into the equation had equaled 0, you should be able to set up your synthetic now. Because if I put in a negative 3 and it's a 0, then you know that it will also be part of a factor. And therefore, this thing will factor. Okay, give it a try. We're almost done. We have a few minutes left of math. Did you put in a negative 3 right here? All right. Just to clarify, if negative 3 is the root, or the 0, then that means it's the thing you'd put in the little box. If it was a factor, it would not be a negative 3. It would be x plus 3. That's the factor for this root. So when this is all factored at the end, I hope you know, you can use x plus 3 and something else. Mr. G, tell me how to do this next part. And how do you start these things? All right, you drop the 1 down. How many of you felt a compulsion to say drop it like it's hot? I did. Snoop Dogg, one of the few helpful math things he's ever said. Okay, then multiply, add, multiply. 0 times the negative 3 makes 0. Add, negative 2, multiply, positive 6. Look at that, it worked out. And I hope you know the reason it worked out is because I had a remainder of 0. Okay. Then, what's the final answer? This comes down, x plus 3. And then this becomes an x squared, and this is an x, and that's a plain constant, and there we go. Do we really have to have the 0x in the middle there? No, I don't. So the final answer is x plus 3 and x squared minus 2. Yes, sir. Can you? I don't think you can, actually. If that had been x squared minus 4, you would have got me, and that does happen. People forget. If this had been a 4 here, it'd be really easy to forget that you could factor it further. But it's a negative 2. It will not factor further. Okay. So, you've learned to factor difficult things using synthetic. You've learned how to write limits. You've learned about polynomials. Do you remember how to tell if something is a polynomial in the first place? Tell me something that's, how about is this a polynomial or not? And if not, why not? Not a polynomial. What do the powers have to be again? You shouldn't say greater than 0. You should say greater than or equal to 1. Counting numbers, yes. Okay. And there was another thing that could mess them up. Because now my function doesn't have an unlimited domain. My function has an issue. It could fail at some point. All right. I think we've pretty thoroughly covered polynomials and kind of be able to predict whether they're going up or down and all that kind of thing. I already showed you what I want you to do for homework. There's a couple long divisions in there that will add something new. And I just encourage you to study by doing practice problems, especially ones that we've gone back and skipped. And that's all I have for you for today.